Easy, don't worry. All right, so two things we're gonna learn: arc length and sector area. Two easy formulas will be a very easy assignment, and we'll get to close out 6.1 here soon. So let's go ahead and just jump into it. That is not right. There we go. Okay, arc length. Just to record the screen. Yeah, I do it sometimes.
Shut up now.
I might record it again. I don't know. Sometimes I do my fifth period class. A little bit, yeah. 10th period's the worst.
Oh no.
Yeah, I've had to walk into that class and I'm like, I don't think that's
I don't want to imagine that.
So, anyhow, arc length. Anybody know what arc length is? Okay, what's an arc?
It's a
boat.
Video game, bro.
You think of arc like a curved line, right? It's an arc boat. So an arc, if we were to start from the middle of a circle, it'd be a different kind of arc. Yeah. Noah's arc is ARK. This is ARC. But yeah. But it is, if you think of like the shape of the boat, it's kind of like the shape of an arc. Right? So this is an arc. An arc is basically this distance from here along here, this curved distance here. That is an arc. So it's like a distance kind of around the outside of a circle. This angle right here, this angle is called a central angle. Right there. So an arc, by definition, it's the distance along the curved line, which is an arc, on the outside of a circle. So outside of a circle, it's the distance along the curved line. That's what an arc. Curved. So that curved line kind of on the outside of the circle. And the length of it is, well, it's the distance along it. So if you were to walk along that outside of the circle, that would be arc length. It's a very easy formula. There's a couple different ways to write this formula, so it won't always look exactly the same, but I'm giving this one to you the easiest way to do it. This is it here. S equals theta over 360 times 2 pi r. And we'll talk about what this actually means in a sec here. So what do you think S represents?
Speed.
What are we trying to find?
Physics. That means arc length is.
Yeah, it's the arc length, probably, right? So S is arc length.
Something about angles, right?
Yeah, so this is arc length S. Equals, so theta, what do you think theta represents?
It's angular something.
Angle, right? So theta is the central angle. The central angle is just an angle formed by like the middle of the circle and some outside. It's like if the angle is the two parts of the angle go from the middle of the circle to the outside. That's called a central angle. So it is central angle over 360. Because there's 360 degrees in the circle, right? So this is like the portion of it. So how many of the total 360 there is? And then what is 2 pi r?
2 times 5.
Right. What is this? This is actually another formula. 2 pi r. Circumference. Circumference is around the outside. So it's like we're just taking the portion of the circle, okay? You know, there's 360 total, so we're just taking a fraction of that, however much our angle is, times it by the total length around. So that makes sense. So obviously 2 pi, and then the radius. So all we need is the central angle and a radius. That's where arc length comes from. This is sort of like a portion of the entire triangle times the circumference. Should make logical sense. So that's arc length.
Given not please knowing 1.5 and 12%.
The only form that is?
Yeah,
Huh.
I was measuring
I
it.
wonder
So we're gonna look at a quick video of one example of a problem, and then we're gonna do the other one as well. This one is this one's for Hunter here.
Me?
Yeah.
Why?
Let's see.
It's basically like just like a video.
You'll see. I was on the so you'll see.
Yeah.
Okay, so our second example takes us out to a track and field event. Jordan and Tyler are teammates and partners on a relay race, and they're running on a curved track with a radius of 25 meters. We also know that Jordan's location is 153 degrees away from Tyler's. Now what we want to find is the distance on the track between the two runners. So let's go ahead and visualize that curved racetrack. And since Tyler and Jordan are in a relay race, they're spread apart. They're on different locations on the track, and they have to meet each other and pass off a baton. So let's call Jordan's location J and Tyler's location T. Now we already know that the radius of the curved portion of the track is 25 meters long. We also know that Jordan's location on the track is 153 degrees away from Tyler's.
All right. So that's enough information to solve it there. So from the center of the track out to looks like he's in the furthest lane is a radius. This is a radius here, 25 meters. And then the angle between them, this is a central angle from the center to the outside, is 153 degrees. Just see if you guys can calculate the distance between them. So this is the arc length, the distance that you would have to run. If you didn't write down the formula, too bad.
You know that
Today,
means
aren't you?
What's down?
360 goes 2 pi r.
How do you do it? 2 pi r? How do you find that?
You'll just, so I would just put it, and just like that, actually, you can do that. You can just do a parenthesis, and then you're just going to do 153 divided by 360. Close parenthesis. You could do times if you want to, times 2 times pi, or just do times 2 pi r. This is probably how I would type it in. I'll show you. I would do s equals 153 slash 360, close parenthesis, times 2 pi, and then parenthesis, my r, which is 25. Yeah, so you should get 66 point, we'll say 8. And the answer, it uses a slightly different version of the formula. It kind of simplifies it into theta over 180 times pi r, which is fine way to do as well. So you can actually simplify the formula to that. Yeah.
The curved portion of the track is 25 meters long. Again, here we just need two pieces of formula. Replace theta with 153. The two runners to be 66.8 meters on the track. Thank you again, everyone, for joining us, and please read.
X out of here.
I don't see myself doing that right before I'm about done.
Well, you can see how it actually is
In the
applicable,
real
right?
world, if you ever want to see the distance between two runners, you just use your eyes, turn the ankle, and that's how far away.
I'll just say about that.
You're not-
So the other one that we have is called sector area. So it's almost the same thing. Have this same idea here. Central angle. Right. And now we're talking about area. So sector is like a piece of the circle. Think of this as like a giant pizza, and you're trying to find the area of your slice of pizza. So that is the sector area, the shaded area. I actually just went to. You ever been to Mellow Mushroom before?
Yeah.
I just went there. It was really good.
Have you ever had the B11? It's like a pizza shop in
I've heard of it.
It's really, really good.
What's your favorite?
Little Caesars.
Little Caesar.
Yeah.
Bro, I don't. Not ready.
The breadsticks are so good. It's cheap and it's good.
It's not bad, yeah.
Not bad. Oh no, man! Pizza cottage is kind of bang.
Pizza cottage.
Because it's drenched in Italian grease. That's how Italian pepperoni.
So the sector area, it's an area of a section formed by an arc in the central angle. So formed by an arc. This is the arc. And then this is the central angle here. And the central angle. And now this is the arc with this one. So when those two intersect there, the area inside is called a sector area. So I don't know, maybe they should call pizza sectors instead of slices.
The day that they start doing that, I'm not gonna be a part of this country.
I don't think that's gonna
Poor
happen.
math standards is taking over my
I'd like to make a pizza place called Sector Pizza.
There you go, that sounds good. Yeah.
So the best restaurant would be called I don't know.
Yeah.
Because it's just how everybody answers all the time.
Right.
Some Sector Pizza. See, that sounds
If you want a sector of pizza, oh, that made me angry.
That's a technical mathematical name for it, right? Sector.
Yeah, we're not calling it a slice. We're not even calling pizza cottage.
So here's the formula. Theta over 360 times pi r squared. So maybe you can recognize like part of that formula as well.
What's theta?
Theta is just the angle, it's the central angle.
I know we just talked about it, but I was trying to figure out my calculator.
Theta is just a symbol, it's a Greek letter that you just use to represent angles. So what is this pi r squared? What formula is that? Huh? Not diameter, that'd be 2r, 2 degrees. What is another formula? You guys actually said on the last one. Pi r squared. Yeah, this is the area of a circle. So basically, we're taking the whole area of a circle, and then we're multiplying it by just the sort of little angle that we have there, the portion of the 360, right? So it should make sense. Just like the other one was like the portion of the 360 times whatever the circumference was, the distance around. This one is the portion of the 360 times the area. So the bigger the angle is, the more sector area it'll be. So I think it's pretty self-explanatory. This is area equals the central angle over 360 times pi times the radius squared. Right. We got a real world problem for this one as well.
What's up, everybody, and welcome to this lesson on arc lengths and sector areas in the real world. So let's go ahead and jump right into our first example here, and we'll start off by highlighting the key information. We have a 14.75 inch long windshield wiper blade that is swiping up and down on an arc with an angle of 132 degrees. And what we want to find is how many square inches of the windshield surface is the blade covering on any given swipe. So first thing I do is I visualize the front windshield of a car, and actually in my mind I don't like this color, so let's go ahead and change it. That's better. Okay, so now that we're going to roll with the chrome pink colored car, we really only want to focus on just that front windshield. Let's go ahead and zoom in on that area. So
Yeah,
as
that's
our
how-
blade
that's
moves
what-
on an arc, it's covering a portion of that windshield, and you want to know how many square inches is the area of that space that's being covered by the windshield
I
as
mean,
it
yeah, they
slides
can
back and
determine
forth.
how much area it's going to cover.
Now we know the length of the wiper blade, our radius is
So
14.75,
like when you're
and the
designing
measure of the central angle.
whoever's designing windshield wipers is going to want to design it to fit into the windshield.
Yeah. I know how they work.
I know how to put them on. It took me 30 minutes to learn how. That was rough.
I just had my dad for that.
I wish I had that.
So go ahead and find the center area here.
250.
So area is the angle over 360, theta over 360 times pi r squared. These are easy formulas to remember because if you know the circumference and you know the area formulas for circles, it's just going to be whatever the angle is over 360, either times the circumference or times the area.
250.
Sounds right. I haven't done it yet. Yeah, so how I would type it in 132 divided by 360, and then I would do times pi, and then parenthesis 14.75 squared like that. Yeah, I got 250.6. So that's it. That's pretty easy.
Angle is meet the value of theta and the length of the radius. We know that theta is 132 degrees, and we know that the radius is 14.75 inches. All we have to do now is substitute those values into the equation and solve. So replace theta with 132.
So to practice this,
R squared was 14.75 squared. And then
we've got a short delta math assignment. It won't take you that long. You might still be able to finish it before you leave. You've got some arc length. So it gives you an angle here. It gives you the measure of some angle, RST. That's the central angle, 56 degrees. And it gives you, it's always going to give you a radius. So it says RS, that's just basically the length of a radius. Here is 19. So for arc length, that's just going to be 56 over 360. And then times 2 pi r, so times 2 pi, and then the radius. And that's your answer. Just make sure you round to the nearest hundred. So you're just going to use one of those two formulas and round it to the nearest hundred. So you've got 8 of those for arc length. And it's just the same basic formula every time. And then also 8 for